Hello, this is luckiest maths teacher in the world. Thank you so much for tuning in as we conclude our section on index laws. We're going to go through a few more today. So let's get straight into it. So what is 2 to the power of 0? A lot of people will instinctively say, oh yeah, that's got to be 0. And that sort of makes sense. But actually, 2 to the power of 0 is 1. And I'll tell you why. So we're going to use our other index laws that we went through last time. So 2 to the power of 4, I'm just picking a random power. I could have chosen 2 to the power of 20, 2 to the power of 5, whatever. 2 to the power of 4 divided by 2 to the power of 4, right? Well, using our second index law from last time, if you divide the bases, you keep the same base and you subtract the powers. And of course, 4 minus 4 is just 0. So 2 to the power of 4 divided by 2 to the power of 4 is 2 to the power of 0. But hang on a minute, 2 to the power of 4 is just 16. It's just 2 times itself 4 times. 16 divided by 16 equals 1. So how does that work? Well, the only way it can work is if this and this are the same thing. 2 to the power of 0 actually equals 1. I could have used another base for that. I could have used 3, 4, 5, whatever, and I would have got the same logic. Anything to the power of 0 except 0 is 1. So we write it like this. X to the power of 0 is 1 if x is not equal to 0. The reason is because 2 to the power of 0, 3 to the power of 0, 1 to the power of 0 and all that is dividing a number by itself. 10 to the power of 0 is like 10 to the power of 5 divide 10 to the power of 5, which is 1. It doesn't work for 0 because 0 divided by itself is not 1. It's undefined. So 0 to the power of 0 doesn't exist. Okay? So 0 to the power of 0 doesn't exist, but 1 to the power of 0 is 1. 2 to the power of 0 is 1. 3 to the power of 0 is 1, and so on. So let's just look at a few quick examples. So let's say we have 7 to the power of 0. It's just 1. What if I had 8 to the power of 0 plus 1? That is just 1 plus 1, which is 2. If I have something like 7 times 3 to the power of 0, so this is a little tricky. Remember we did order of operations a few weeks ago? Raised to the power comes first. So this here is 7 times 3 to the power of 0, which is 1. And 7 times 1 is 7. So make sure you understand that. All right, we're going to go through another index law now. 2. So what about if we have something like this? What if I have 2 to the power of 5 and I raise it to the power of 3? So I'm raising a power, an index, to another power index. So remember that if I cube something, raise it to the power of 3, it means you multiply it by itself 3 times. So this is 2 to the power of 5 times 2 to the power of 5 times 2 to the power of 5. But from our index laws last time, when you multiply bases together, you add the powers. So this is just 2 to the power of 15. Note, what I'm doing is adding this number this many times. Or if you like, this many groups of this. And hopefully when I said groups of, your eyes lit up and you thought, oh, multiplication. So we're multiplying this number by this number, and that works all the time. So that's our next index law. So if I have a to the power of b and I raise it to another power, I keep the same base, just like I did here, and I multiply the powers together. So let's look at a few examples. So let's have 3 to the power of 8, and I raise that to the power of 6. So that would be 3 to the power of 8 times 6, which is 48. Okay? Note, I'm not adding the powers here. So let's say I have 6 to the power of 11 to the power of 0. So keep the same base, and I multiply the 2 powers together. So 11 times 0 is just 0. So this would actually be 1. Okay? Now what if I had something like this? What if I had, say, times, let's say, 3 squared to the power of 5? Well, what you do in that case is you raise everything in the brackets to that power. So I raise 2 to the power of 5 and times that by 3 squared to the power of 5. And again, I'm just going to multiply the two powers together. Okay, another example. Let's say I had 8 to the power of 4 times 5 squared, and I raise that to the power of 7. So I do the first thing, raise that to the power of 7, so keep the same base. 4 times 7 is 28. 5 squared to the power of 7, keep the same base, and I multiply the two powers together, and then I'm done. Okay, so I'll just give a summary of the index laws that we've gone through. So these are the two index laws we've gone through today. So anything to the power of 0 except 0 is equal to 1. And the next one, if you raise a power to a power, you keep the same base and multiply the two powers together. So because of this law, we can write another law like this. If you have two things inside a bracket and they're raised to a power, raise the first thing to that power, raise the second thing to that power. That can also be used for fractions. So if you have a fraction raised to a power, you just raise the top to that power and raise the bottom to that power. So these two are useful to know, but they're basically consequences of the second index law. So the reason that we have both of these index laws in black is just from the index laws we learned last time. So this is true from the index law where we divide bases and subtract the powers. This is true because of the index law where we multiply bases, we add the powers. All right, hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.